Hello and welcome everyone. In this video, we'll be discussing about greatest integer or floor function. Floor function, it is a special type of function like that of signum function. What you said previously, it has special characteristics. The floor function, as you see here, the definition, it is a function f of x, which will be written in the form or denoted by down closed interval x. We are going to consider any number. Okay, the outcome will be any number which must be less or equal to x, any integer number. It has to be less or equal to the number what is mentioned in the bracket here. So when you define floor function, we need to consider ceiling function at the same time. Floor function is a function f of x which will be written in the form down closed x, and ceiling function we can say it is g of x which will be upper closed interval x. For example, in a number line we can take 1 and 2. If I take a number 1.5, what will be the floor of 1.5 and what will be the ceiling of 1.5? When we are saying floor, we are going to think of the bottom or the number which is at the back or to the left side of the given number. Now, the given number, we are talking about 1.5. What is the integer which is found to the left side of 1.5? That is floor. For example, f of 1.5 will be just 1. Because we have to think of a number which is an integer number. It has to be integer to the left side of the given number. Less than or equal to. It says not necessarily always to the left side, it says less than or equal to. If the number is like whole number, for example, if we can consider like f of 2, it is just 2. What is the number less than or equal to, or what the integer less than or equal to 2? So just 2. But if it is decimal, like that I take here 1.5, we have to think of the number or the integer to the left hand side. When we are saying ceiling, we have to think of the integer to the right side of it, the next integer. This integer is going to be now g of 1.5 is going to be 2. So the formal definition this time, or we are trying to define what means floor or greatest integer function. If the number is negative, for example, instead of like 1.5, what if it is f of negative 1.5? First, let's think of negative 1.5, where it is found. If negative 1 here, negative 2 will be here. So negative 1.5 will be found at the middle of negative 2 and negative 1. So the floor of negative 1.5, we have to think of to the left-hand side of negative 1.5, that an integer to the left-hand side of negative 1.5, necessarily that will be negative 2. But if it is g of negative 1.5, we need to think of an integer to the right side of negative 1.5. That number has to be negative 1. So this is the main definition, but if the number is whole number, either 0 or any other like integer, the outcome will be the integer itself. But if the number is not integer, it is decimal, we can take, in case of floor, we need to think of the number, which is the integer which is found to the left side of the number. If it is ceiling, we need to think of the integer which is found to the right side of the integer. Let us see some example here. The first example, it says the number is pi. So we are asked to find the floor of pi. Pi by itself is 3.14. So the floor of 3.14 is just 3. Look, this is the answer for A. Look B. We are asked the floor of negative 21.01. We are thinking of, or we have to think of a number which is found, or an integer which is found to the left side of negative 21.01, necessarily negative 22. Look C, the floor of 21.01, it must be 21. If the number is positive, take the digit which is before the decimal point, as it is. Look, 3 point whatever, it will be 3. 21 point whatever, it will be 21. If it is negative, just add on it, on the magnitude. 21 plus 1 will be 22, but still negative. Don't forget that. Look D, the floor of 0. If it is just an integer, take it as it is. This will be the answer. Next example. The next example, it says verify. Verify f of x is less or equal to x and less than f of x plus 1. What is x? A, when x is equal to 2.5. That means f of 2.5 is less or equal to x, 2.5, and less than f of 2.5 plus 1. Normally, f of x is defined by floor x. Don't forget that. So what is the floor of 2.5? Just 2 is less or equal to 2.5 is less than, again, the floor of 2.5 will be 2, because f of x is floor x, means we need to insert 2.5 on the floor. Floor of 2.5 will be just 2. So 2.5, again, floor of 2.5 is 2 plus 1. So 2 is less or equal to 2.5, which is less than 3. That is true, and it is verified. We are asked to verify whether this property works or not by substituting x equal to 2.5. Then we did it. Finally, we arrive at this point, which is true statement. 2 is less or equal to 2.5, yes, and 2.5 is less than 3, correct? So that is true and verified. You can do the other in the same manner. One last example, here it is. Actually, this is not example, but exam type of question. It says f of x, f is greatest integer. That means f of x, we can say, is equal to floor x, and g is absolute value function. That means, again, we can take g of x is equal to absolute value of x. Then what is the value of f compose g of 5 over 2 plus g compose f of negative 8 over 3? This means f of g of 5 over 2 means 2.5. I can take plus g of f of negative 8 over 3. Negative 8 over 3 means we can write it in decimal form. That is negative 2.66, nearly. So g of 2.5 means absolute value of 2.5, because the g is taking the number, or whatever the number you insert here, in place of g, you are going to insert in absolute value. So it will be 2.5 as it is. F of 2.5 remain plus g of f of negative 2.66 means we need to think of the floor of this number, or we need to think of a number which is the left hand side of this decimal, that is negative 3. Then the floor of 2.5 will be 2 plus an absolute value of negative 3, because g is taking and putting in absolute value, so it will be just 3. So the sum of this number will be 5. So this is a combination of two different kind of function, but we can see the application of, or the use of floor x in this question. So this is the way how we can practice using floor x or greatest integer function, but don't forget at the same time ceiling function. You don't have to be new when ceiling is defined. Thank you for watching.